The topic is sorting technique. There are various sorting techniques. Here I have a list of sorting techniques that I am going to discuss. So many sorting techniques are there. Each has its own method of working. We cannot say one of the sorting technique is a best sorting technique. There is some criteria. Based on that, we compare the sorting techniques, and suitable for your requirement, you can select a particular sorting technique. So what is the criteria for comparing those sorting techniques? So first of all, we should know the criteria of comparison of those sorting techniques. Based on the criteria, we will be studying them and analyzing them. So first of all, let us discuss criteria. See, sorting techniques are analyzed based on number of comparisons. For sorting the elements, a sorting technique may be comparing the elements, and if it is comparing, then total how many comparisons it is performing. So actually total time taken by a sorting technique depends on the number of comparisons only. So this number of comparisons decides the time complexity of any sorting technique. Then the second one is how many swaps. See, for arranging them in the order, increasing or decreasing order, the numbers has to change their places. So it has to swap the elements. So swapping is a common process done in almost all the sorting techniques. So how many swaps it is performing? We will analyze how many swaps a sorting techniques is performing. Then third one is adaptive. See, when you are trying to keep the elements in the sorted order, what happens if they are already in the sorted order? Already they are in increasing order and I am trying to arrange them again in increasing order. So if they are already in increasing order, then the sorting method must take minimum time or a less amount of time, because it doesn't have to rearrange the elements. So if any sorting method is taking less time or minimum time over already sorted list, then we call that algorithm as adaptive. So sorting procedure or algorithm, we call it as adaptive algorithm. Then this I have to explain you using an example. What does it mean by stable? So I will finish this. Extra memory. Out of these sorting algorithms, there are some sorting algorithms which requires extra memory space for sorting the elements. Apart from the space consumed by the element, they need extra spaces. So not all, few require that. So we will analyze for every algorithm whether it requires extra space or not. Then I have to explain you stable. So I'll remove this and take an example to show you what is the meaning of stable and importance of stable. Now let me explain you what does it mean by stable. For explanation, I have list of names and marks. Actually, these are records of students. Suppose these are student names. I have taken just alphabets, names of the student and their marks, right? Now this list is already sorted based on names. Now I want to sort based on marks. So if you look into the marks, two students are having same marks. First is C, then next is E. So there are duplicate elements. When I sort this based on marks, what I want is their order should not change. That this 6 should come first, then this 6. What is the difference? Both are 6 only, no? No, that is the reason I have kept other values also here. This 6 belongs to C, this 6 belongs to E. So that C should come first, then comes E. The order should be preserved. If a sorting algorithm is preserving the order of duplicate elements in the sorted list, then that algorithm is called as stable. Let me sort this and show you. Lowest marks, smallest marks are 4. So D 4. The next is A 5. The next is 6. So which 6 I should take first? This one only. So if I am getting C6 then E6, then we say that the sorting procedure is stable. If any of the sort is preserving their order as it is, then we call that sorting procedure as stable sorting or stable algorithm for sorting. I'll finish this, I'll write the rest of the numbers also. So stable means if there are any duplicate elements in the original list, then in the sorted list, their order must be preserved. Now next question, why? Why we need this? Reason, listen. See, already this list was sorted based on names. Now I am sorting them based on marks. If I sort them based on marks, it will not be sorted upon names. No more, definitely. See, the names are different, D, A, so they have changed their order. But if there are duplicate marks, then at least their names must be in the sorted order. First C, then E. This is the requirement. If you are sorting a record upon multiple columns, name, then roll number, then marks, like this, if you are sorting them, then this is the requirement. First sorting was this one. Now when we sort upon marks, that is lost, but it will be preserved if duplicates are there. So this is commonly used in databases. So we want a sorting algorithm in database such that if you are sorting upon multiple columns, then it should preserve the result of first sort in the second sort. Means if there are duplicates, then their order should be preserved. This is the requirement. So not all algorithms are stable, few are stable, I will show them. So that's all, we have finished with the criteria for analyzing sorting algorithms. Now I'll briefly give you the idea about all these sortings. I have listed them, then briefly I will talk about them. We are going to learn about all these sortings one by one, but just let us get a broader picture of all these together. See, all these sorting algorithms from 1 to 8, these are called as comparison based sorts. All these are comparison based sorts. They sort the elements by comparing with other elements. So one element is compared with other elements and their arrangement is done. Then what about these sorts? These three sorts are called as index based sorts. So these are index based and these are comparison based. Next, these sortings, these three sortings, they all take n square time. So we commonly say n square sorting algorithm, means we are referring to those three. They all take n square. We will analyze this one. When we study, we will analyze this. Just I am giving the overview about this. Then these algorithms takes n log n time. N log n sorting means any of these. Heap sort, merge sort, quick sort, tree sort. N log n sorting means any of these. N square sorting means any one of those. Now these sortings are, so these are order of n or multiple of n, but they consume a lot of space. So they are faster, but space consumption is more. This sorting is n power 3 by 2. So it is faster than this one, but slower than n log n. Shell sort, it's 3 by 2, 1.5, n power 1.5. Anyway, adopt, which one is adaptive, which one is stable, I am going to explain it along with the algorithm. When I discuss it, I'll analyze it thoroughly. Just I wanted to show you that some are comparison based sorts and some are index based and some are n square and some are n log n. This categorization you must be familiar with. So that's all. We will be starting from bubble sort.